Hey everyone, Mr. Regan here, and today we're going to be looking at how to identify criteria and constraints when creating a solution to a problem or completing a task. We're going to look at how we figure out whether we're looking at a criteria or a constraint depending on how we design solutions to solve those problems and complete those tasks. And then we're going to look at some examples to kind of help us narrow our understanding and begin applying it to the task at hand with our paper plane challenge. So we're going to start by looking at the criteria, then we're going to look at the constraints, and then we're going to kind of compare and contrast so we can help ourselves identify the differences and even some of the similarities again as we move forward. So let's go ahead and look at criteria. Criteria, when we have the definition in front of us, the requirements we use to determine if the solution to a problem or task is successful. So the key words here are the requirements. Okay, and we use these requirements to determine if the solution or the problem to a task is successful. So these are requirements we use to determine if something is successful. Okay, so that is a criteria. And now when we look at constraints, these are the limitations put on the criteria when designing a solution or a problem to the task. So big key here is the limitations put on the criteria, again, when designing that solution, problem, or task. So these are the requirements to be successful. These are the limitations on the criteria. So those are the two big differences when we're looking at the comparing of the definitions there. So because they're so similar and slightly different, there's a few ways we can go about determining whenever we're trying to solve a problem or create a design that is the solution to a problem. There are different ways we can look at figuring out whether something is a criteria or a constraint, okay? So the first way is by using a basic question we can ask ourselves as we're looking at the overall problem or the challenge in this case. And that question when we determine the criteria is, what must be done to have a successful solution? So whenever we look at a challenge or a problem or a task at hand, if we ask ourselves, what must be done to have a successful solution? This can help us narrow down whether or not we're looking at a criteria or a constraint to our overall problem. When deciding whether something is a constraint, we can ask ourselves what restrictions make it more difficult to complete the criteria. Okay, so what must be done to make the solution successful? What restrictions make it more difficult? So if you notice the questions, very different, okay? One focusing on the restrictions, one focusing on what must be done to be successful, okay? Now, using these questions can help narrow if something's criteria or constraint, but it is not always the best way. We also need to look at the problem and the challenge or the task from a qualitative or quantitative lens. So qualitative, think of the word qualities, okay? So the qualities of the design that can be changed or influenced in different ways to complete the task or provide a solution. So this is looking at what we can influence, what we can change, what we have control over. On the other side, we have quantitative aspects. So in other words, quantitative things, think of quantities or numbers. So these are specific measurements or quantities that must be applied to the design in order to tailor the solution to a specific problem. So that's kind of key here. Over here, it's looking at things that we can control or influence. Over here, these are specific measurements or quantities that are tailored to the solution. So things we really don't have control over. So again, the question and the qualitative, focuses here help us narrow if something's a criteria versus the questions and quantitative aspects help us narrow it down to constraints. So now let's look at some examples here. If you notice, we have some car pictures on the side. So an example, when we look at criteria, so maybe you're a business that makes cars, right? And as a business, you've decided that you have some criteria that must be met when it comes to building your cars. So the criteria for building a reliable family car might be, well, you have to create a car. It has to be reliable, and it has to be made for a family. So when we look at these three things, we can ask ourselves, what must be done to have a successful solution? Well, it has to be a car that's made, can't be a motorcycle, can't be a boat, has to be reliable, okay? So it has to be something people look at and say that has value and can be relied upon. And last but not least, it has to be made for a family, okay? Can't be a single person or a couple, but a family. These are all criteria that have to be made. Now, when we look at Qualities of the design that can be changed or influenced in different ways. Well, if you look at these three things, there's a lot of things you can do to change or influence what a car is or what makes it reliable. So, for example, okay, there are a lot of different solutions and different car choices you can create. Okay, pickups versus compact versus standard versus so on and so forth. Again, a lot of things that you can change or influence. Has to be reliable. So what makes cars reliable? Well, that's usually their safety features. So again, we can have different safety features in the car, whether it's things that can be detected, whether it's a safety belt, whether it's certain options to the type of metal you used. Again, all different features that you can have or not have to make it more or less reliable. And then last but not least, has to be made for a family. Well, when it comes to a car, if in order to have a family, you need to be able to fit a family. So you can have different seating arrangements that have different amounts of people. Again, these are all things that you, if you're the car company and you're designing this car, can influence or change. So these are all different criteria that have different solutions. So now let's look at it from the constraint perspective. So maybe some constraints that are placed on the creation of your car might be, well, it has to have 4 wheels, okay? You can't create a 6-wheeled or 3-wheeled car. Okay, it has to be 4 wheels in order to be considered a car. So though your constraints are 4 wheels, okay, this makes it a constraint. There is a level to this that is also a criteria. So you need to have 4 wheels, but those wheels can be different. So again, the 4 wheels makes it a constraint, but the type of wheel you use makes it a criteria. So notice, okay, when we ask ourselves the question, what restrictions make it more difficult? Well, we know we have to use 4 wheels. We can't use 5, can't use 6, has to travel on 4, okay? Specific measurements or quantities. Well, we know we have 4. 4 is a measurement. It's a quantity that we have to have. All right, let's look at the next one. Has to travel 50 miles without being fixed, or 50,000 miles, without being fixed. So that's looking at the speedometer of your car. Now notice we have to be able to travel 50,000 miles without being fixed, okay? That's a specific restriction, okay? And that's a measurement or quantity that's applied. So notice 50,000, that's specific quantitative information. Now, many of you are probably thinking to yourself, well, if we do this, okay, doesn't that make our solution successful? Doesn't that determine if it's successful? And when you think of it that way, you're right. But remember, the second part is you need to be able to change or influence that specific thing. In this case, you can't influence or have less miles. You have to have 50,000 or more. Okay, so that's key. Restrictions versus things that you can change or influence. Last but not least, needs to fit a minimum of 4 people. Again, so we have to have a car, minimum of 4. You could have 5, you could have 6. But again, there's that restriction, that quantitative data and information that is required. So we have our criteria, we have our constraints, and when we look at these two things together, scientists are able to then decide how to best create a solution for whatever problem or task they have at hand.